Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to go over how to calculate the total vapor pressure of a mixture of volatile substances. So let's get into this. So in this question or problem, we're given a liquid solution that consists of 0.35 mole fraction of ethylene dibromide, and we're given the formula here, C2H4Br2, and 0.65 mole fraction propylene dibromide. And again, we're given the formula here, C3H6Br2. Both of these liquids are volatile. That means that they are both able to evaporate. And they want us to calculate the total vapor pressure of the solution, assuming that the solution is ideal. So what does it mean for a solution to be ideal? What that simply means is that the interactions between the solvent and solute particles are going to be exactly the same, or are assumed to be no different than the solute-solute interactions and the solvent-solvent interactions. So when they mix together, there's no change or no difference in the interactions of the particles as when they were separated from each other. And so the way we can solve this problem is to calculate the partial pressure of each of the substances in the mixture according to their mole fractions, and then add those partial pressures together. So we're going to use Raoult's law twice. We're going to use Raoult's law here. So Raoult's law says that the partial pressure or vapor pressure of substance A in a solution is going to be equal to the mole fraction of that substance in the solution multiplied by the partial pressure of the pure substance. Since we have a couple of substances mixed together, we would do this for substance A, and then we would do it for substance B, and then add those together. So let's go ahead and do that. So for our first substance is the ethylene dibromide. So we're given that the vapor pressure of the pure substance of ethylene dibromide is 173 millimeters of mercury at 85 degrees Celsius. So what we're going to do is we're going to take, that will be substance A. So what we're going to do is that's going to be equal to the mole fraction. We're given the mole fraction is 0.35. So then that's going to be equal to 0.35. And we're going to multiply that by the vapor pressure of the pure substance, which is here 173 millimeters of mercury. So we're going to multiply that by 173 millimeters of mercury. And when we calculate that, we get 66.55, or let me double check, 60.55 millimeters of mercury. So that is for the ethylene bromide. So we'll write that down here, C2H4Br2. And then for substance B, that'll be our propylene dibromide. So we'll say the pressure or the partial pressure of B is equal to, and that's our ethylene dibromide right here, or propylene dibromide, sorry. So that'll be the mole fraction of the propylene dibromide multiplied by the vapor pressure of the ethylene dibromide that is pure. And so we're given that the mole fraction of propylene dibromide is there. I think I kept saying ethylene dibromide. We're talking about propylene dibromide right now. Sorry. So we got the propylene dibromide mole fraction 0.65, and you'll notice that Both of these added up equals 1. So that's the total number of substances in the solution. So there's no water in here. We don't need to calculate that for water because the 0.35 and 0.65 add up to 1. So basically, these two alone make up the total amount, a fractional amount. So we're going to take this mole fraction of our propylene dibromide and multiply by the vapor pressure of the pure propylene dibromide, which is 124 millimeters mercury. So 124 millimeters of mercury. And we're going to equal, when we calculate this, we get 80.6. So 80.6 millimeters of mercury, millimeters mercury of the propylene dibromide. Okay. Now that we have the vapor pressure due to both of these substances in our solution, then to get the total vapor pressure, we just add these together. And when we add these together, we get 141.15 millimeters of mercury. So that's the total vapor pressure of our solution. So now sig figs, if you want to know how many sig figs to keep, we got to go back to our original answers here. So here we have 3 sig figs given. Here we have 2 sig figs given. So when you multiply these together, your answer should have 2 sig figs. So the final sig fig in here is going to be in the ones place. Same thing here. You multiply these together. This should have 2 sig figs. So we have 2 sig figs here. So our final answer there. The last sig fig is in the ones place. But we're not done with our calculation. So you want to keep at least 1 extra digit. So here I have 2. Here I have 1. So I'm keeping an extra digit to avoid the rounding errors. So then now the rule here when I'm adding is that my answer should have the least number of decimal places or have the least precision as the least precise measurement that I'm adding together. So you'll notice here that both of these, the least precision is in the ones place. So that means that my final answer here, I'm limited to the ones place. I can't go past the ones place. So therefore, I would get rid of this, and my final answer would be 141 millimeters of mercury. And that, ladies and gentlemen, is the final answer. I hope you enjoyed this video. If you learned a lot from this video, if this helped you out in any way, then please, by all means, like the video, share the video, hit that like button somewhere over there. I know you can find it. Also, do me a favor, help me out. Subscribe to the channel, hit that notification bell right up there somewhere. If you hit the notification bell, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you need help with, if you have a topic you want me to cover, let me know down below. Thanks for joining me and have a great day.